Welcome to G Fun Facts Online. If you look up at the night sky, especially in the Northern Hemisphere's winter, one star demands attention. It's the bright, distinctly reddish point of light on the shoulder of Orion the Hunter. This is Betelgeuse, a celestial celebrity, one of the most recognized stars in our galaxy. But for more than a century, this familiar supergiant has been hiding a profound secret. A cosmic companion that has orchestrated its bizarre behavior from the shadows. And now, that secret is finally out. For over 100 years, astronomers have been captivated by Betelgeuse's enigmatic nature. It doesn't shine with the steady, reliable light of a star like our Sun. Instead, its brightness fluctuates wildly. These changes were most famously observed during what became known as the Great Dimming in late 2019 and early 2020, when Betelgeuse faded so dramatically that it was visibly dimmer to the naked eye, sparking widespread speculation that it was about to explode as a supernova. While that particular event was later attributed to a massive cloud of dust ejected by the star itself, it drew global attention to its inherent instability. But beyond these chaotic outbursts, astronomers had also detected a much more regular underlying rhythm, a subtle 6-year cycle of brightening and dimming. This periodic pulse was the real puzzle. Theories like giant convection cells, star-sized bubbles of hot gas rising and falling, could explain some of the chaotic variability, but they couldn't account for such a consistent 6-year clockwork. The persistence of this cycle hinted at something else, something with a gravitational influence, something orbiting the star. The idea that Betelgeuse wasn't alone dates back to 1908. An astronomer named Henry Cozier Plummer was studying the star's movement and noticed something odd. By analyzing the star's light, he could see it wasn't just sitting still, it was wobbling, moving slightly towards us and then away from us. This is called its radial velocity. Plummer suggested that the most logical explanation for this wobble was the gravitational tug of an unseen companion star, pulling Betelgeuse back and forth in a cosmic dance. For the next century, this ghostly companion theory remained the leading hypothesis, but proving it was a monumental challenge. Imagine trying to photograph a tiny candle flame right next to a giant stadium searchlight. Betelgeuse is so incredibly bright that its glare completely overwhelms the faint light of anything nearby. It's thousands of times brighter than its suspected partner. Even the world's most powerful observatories, including the Hubble Space Telescope and the Chandra X-ray Observatory, had pointed their gaze at Betelgeuse and found nothing. The companion remained elusive. The breakthrough finally came from a team led by NASA research scientist Steve Howell, using the immense power of the 8.1-meter Gemini North Telescope. Perched high atop the dormant volcano Mauna Kea in Hawaii, this location provides some of the clearest, most stable atmospheric conditions on Earth. But even that wasn't enough. The team employed a highly specialized technique called speckle imaging with an instrument named ALOPK. Here's how it works. Earth's atmosphere is constantly churning, which blurs and distorts starlight, causing stars to twinkle. Speckle imaging is like a celestial high-speed camera. It takes thousands of very short exposures, each one fast enough to freeze the atmospheric distortion for a split second, capturing a lucky shot where the view is momentarily clear. Then, powerful computer algorithms stack and process these thousands of individual frames, canceling out the blur and reconstructing a single, ultra-high-resolution image. Pushing this technology to its absolute limits, Howell's team was able to pierce through the blinding glare and, for the first time ever, directly image the faint point of light orbiting Betelgeuse. The century-long hunt was over. The ghost had been found. The newly discovered companion has been nicknamed Siwarha, an Arabic name meaning her bracelet, a beautiful tribute to an object that adorns the giant star. And studying this companion revealed a perfect solution to the long-standing mystery. Siwarha is a relatively small star, estimated to be about 1.5 times the mass of our Sun. It orbits Betelgeuse at a distance of about 4 astronomical units, which is 4 times the distance between the Earth and the Sun. And, in a stunning confirmation of the old theories, its orbital period is 6 years. This was the smoking gun. The 6-year orbit of Siwarha perfectly corresponds to the 6-year cycle of brightening and dimming that had puzzled astronomers for so long. The gravitational interaction between the two stars as they orbit each other is what causes the regular, rhythmic changes in Betelgeuse. The discovery of Siwarha paints a fascinating portrait of a cosmic mismatch. On one hand, you have Betelgeuse, a red supergiant in its cosmic twilight years. It has exhausted the primary hydrogen fuel in its core and has swelled to an almost incomprehensible size. If you were to replace our Sun with Betelgeuse, its surface would extend past Mercury, Venus, Earth, Mars, the asteroid belt, and all the way out to engulf the orbit of Jupiter. Our entire inner solar system would be inside the star. It's a stellar senior citizen, furiously burning through its remaining fuel on its way to its final demise. On the other hand, you have Siwarha. Though born from the same primordial cloud of gas and dust at the same time, it is a hot, young, blue-white star. In fact, it's so young it's not even a fully fledged star yet. It's in a phase known as pre-main sequence, a stellar toddler, still in the process of contracting under its own gravity, heating up on its way to igniting sustained nuclear fusion in its core. How can two siblings be at such different stages of life? The answer is mass. Betelgeuse was born far more massive, causing it to live its life in the fast lane, burning through its fuel at a furious rate and aging rapidly. The smaller, less massive Siwarha is living a much slower, more leisurely existence. While the discovery solved one mystery, it has revealed an even more dramatic story unfolding, a dance of doom. Siwarha's orbit is perilously close. At a distance of 4 astronomical units, it's not just near Betelgeuse, it's actually plowing through the supergiant's incredibly vast, tenuous outer atmosphere, or chromosphere. Imagine a satellite trying to orbit Earth but flying through our upper atmosphere. The result is drag. This constant drag from Betelgeuse's atmospheric gas is stealing Siwarha's orbital energy. With less energy, it can't fight the supergiant's immense gravity, and its orbit is slowly but surely decaying. It is spiraling inward. This stellar dance will end in a dramatic act of cosmic cannibalism. Astronomers predict that within the next 10,000 years, a mere blink of an eye on cosmic timescales, Siwarha will be completely consumed by Betelgeuse. The tidal forces from the supergiant will likely rip the smaller star apart as it gets closer, with its material being stripped away and pulled onto Betelgeuse's surface. This raises a tantalizing question. What happens first? Betelgeuse is destined to explode as a Type II supernova sometime in the next 100,000 years. Its merger with Siwarha is predicted to happen in just 10,000 years. So it seems the cosmic meal will happen before the final explosion. The merger itself could be a spectacular event, possibly causing Betelgeuse to brighten immensely as the two stellar cores combine, triggering a massive expulsion of material into space. The confirmation of Siwarha is more than just a fun fact about a famous star. It has profound implications for our understanding of massive stars throughout the universe. Many other red supergiants exhibit similar variability, and this discovery provides a powerful model to explain their behavior as well. It suggests that having a close companion might be a crucial and common part of the life cycle of these giants. The Betelgeuse-Siwarha system is now a unique, natural laboratory, allowing us to study stellar evolution, mass transfer between stars, and the complex physics of binary interactions in real time. The story is far from over. Astronomers are eagerly awaiting November 2027, when Siwarha will reach its maximum apparent separation from Betelgeuse in its orbit. This will provide another golden opportunity to study the pair in even greater detail, perhaps with new instruments like the James Webb Space Telescope, which might be able to analyze the very light from Siwarha itself. The discovery of Betelgeuse's secret companion is a powerful reminder that the night sky, no matter how familiar it seems, is still full of profound secrets, waiting for our relentless curiosity to unveil them. Thanks for listening to Fun Facts Online.